How's it going, everybody? This is Team 27, including Gregory, Ryan, Ty, Mason, and Akshay. For this project, we're looking into the manual material handling task that UPS, FedEx, and other delivery drivers face every day. So for our proposal, we stated that with the increase in demand for online delivery since the early 2010s, many more package delivery drivers are faced with the risk of WMSDs every day. This job requires a lot of sitting, lifting, and moving packages of various sizes, as well as vibrations from the truck and repetitive movements, which could lead to WMSDs over time. There's a risk for things such as neck, shoulder, and back pain and injuries, as well as tendon issues such as carpal tunnel and tendonitis. So for this project, we're using the ergonomic process, which is a four-step process to evaluate the risks of injury for these workers. The first step is to identify existing or potential risks of WMSDs. Second step is to perform a job analysis. Third step is to implement controls. And the final step is going to be to evaluate the effectiveness of these controls. So for step one, we characterize the existing and potential problems using different databases, journals, and websites online. We found that 61.75% of delivery drivers have present WMSDs. Delivery drivers work on average 8 to 10 hours a day. The average UPS driver delivers 250 boxes per day, each of which weigh on average 15 pounds. And UPS and FedEx ship packages up to 150 pounds. So on the bottom right is the distribution of WMSDs present among affected workers. So there's a whole bunch of different areas in the body. Some of the most popular being knee, neck, shoulders, and low back. For this project, we're going to be focusing on the low back, specifically the L5S1 joint. And the bottom left is the picture of a FedEx worker delivering packages at someone's doorstep. His posture and kind of the style that he's using to deliver the packages is what we're going to be referencing throughout this project.
So for step two of the ergonomics process, we are going to be performing a job analysis. And that can be shown one way by this free body diagram, and that is of the worker down in the left. He is picking up two different boxes, one in each hand, and that can be shown in the free body diagram using forces 4 or 5 for both the hand and the box. Those center masses will be at the end of the forearm, and they are combined. Now, that individual there, the mass of him will be about 73 kilograms, and that is for the 50th percentile worker. The mass of the boxes each is going to be 10 kilograms. And in the drawing, you have a left and a right arm. So those calculations are going to be the same. Down below, you have the moment equation where the perpendicular distance is represented in blue and the forces acting on the person is represented in red, in addition to the moment around the L5S1 joint. At the bottom, we can see that the moment we calculated was 212.8 Newton meters of extension. And we can move on to the next slide. So another analysis that we did was the REBA analysis. And this is for the awkward posture. We scored an 11. And this suggests that it is a very high risk for WMSDs. And so it is very important that we implement a change. Next, we looked at the NIOSH lift equation and calculated that the recommended weight limit was 9.25 kilograms, while the actual load is 14 kilograms. So the lifting index is 1.51, which is an increased risk.
So knowing that this job needs changes, here are our implemented controls. So the known administrative controls are that they teach proper delivery technique at the very beginning, when they're first hired, along with team lifts at loading docks. We suggest to add a pair of workers for high demand routes to be able to rotate through during the work shift, along with adjusting routes to be able to schedule in accommodated breaks to be able to give people enough recovery time to lower the risk. The engineering controls, first we have gloves for the grip of the boxes, along with driving and handling the vibrations. For We also have packaging clamps, which eliminates awkward postures and allows you to keep the boxes at a neutral position when walking and dropping off. And finally, packaging carts eliminates all excessive heavy lifting, along with trying to lift or drop off those boxes. So here's a little example of the package um, clamp design, where it would go around the box and then it would have an easy lift up and then be able to have it with a good grip and walk with it right by your side and then place it on the ground.
Now we'll be taking a look at step four, the ergonomics process, which, as we all know, is to evaluate the effectiveness of the controls. So first, we're going to take a look at the posture improvement before and after we implemented our controls. On the left, we see the poor and awkward posture the worker is at. Oh shit, sorry. Wait, did we get rid of the picture?
Yeah, you're good. We'll just cut this out. But yeah, we can just use that because it's the same thing pretty much.
Oh, sorry, my
Pop
bad.
it out
It
there.
just caught me off guard.
You're good. Just start from the top of this slide.
Okay, yeah. So first, we're going to take a look at the posture improvement before and after we implemented our controls. On the left, we see the poor and awkward posture the worker is at when dropping off packages to the ground. The main concern here is the angle at which the back is when bending over. And now looking at the picture right next to it, it shows the worker's grip of the package from an aerial view. We can see that the hand is extremely stretched out across the width of the box, and the overflexion of the hand and wrist was a big concern for us. And now looking at the posture after we implemented our controls, we can see a few changes. First, the worker is now using a stoop squatting technique, which keeps the back straight all throughout the delivery of the package to the ground. In addition, we added a package clamp, which allows the worker to grasp the handle of the clamp while the package is secured by the tool. This allows the hand and wrist to be in one stable position when handling packages. Now taking a look at the REBA assessment post-implementation, we could see the final score decrease from 11 to 2, and this means the posture went from a very high risk to low risk. And taking a look at our second piece of analysis, we see the recommended weight limit in the NIOSH lift equation increased to 16.55 kilograms. This in turn decreases the value of the lift index to 0.846, which signifies that it's a low risk.
This is our biomechanical evaluation after we implemented our controls. To begin with, we added a new assumption that the center of mass of both the hands, gloves, or of all the hands, gloves, and also the box, we assumed they were all in the same area. As you can see, the new position the worker is in removed the impact of forces 1 and 8 on the L5-S1, which led to a less extreme posture of the worker and reduced the moment but at the L5-S1 by 58% to a value of 87.4 Newton meters, still an extension there. In conclusion, the combination of increasing the frequency of our scheduled breaks and our engineering controls allowed the worker to be in a less extreme position. This led to a significant decrease of the moment at the worker's L5-S1, decreasing it by 58%. The REBA score of the task decreasing from +11 to +2, bringing it into a low risk evaluation. And then the NIOSH lift equation showed a decrease in the lift index from 1.51 to 0.846, bringing the job into an acceptable range. These are all of our references. Then this is the work for all the calculations for the initial biomechanical evaluation. These are the calculations for the revised one. These are our initial NIOSH lift equations calculations. And these are the revised ones. And thank you for listening to our presentation.